Okay, let's try to take the derivative of these two functions just with the rules that we know. So right now, our only option with that squared is we need to write it twice. Okay, a binomial squared, we always write it twice, 3x minus 2 times 3x minus 2. Now, here you have the choice. We can use the product rule, or we can FOIL it out and just use the power rule. So since it's a binomial times a binomial, it's really not that bad to FOIL it out. So let's just do that. Let's do 3x times 3x is 9x squared. The outside gives us negative 6x. The inside gives us negative 6x. So that's negative 12x. And then negative 2 times negative 2 is positive 4. So then when we take the derivative of it, I'm just going to say that this was y. Okay, so that we can say y prime equals 18x minus 12. Okay, we could have also used the product rule, and that's what I'm going to use on the next one, just so that we see a variety here. So we write this twice, x squared plus 4 times x squared plus 4. So if we use the product rule, again, I'm going to call this y, and let's just use our dy over dx notation. So here's our first. So first times the derivative of the second plus the derivative of the first times the second. Now, look at what we've got here. We have two of the exact same expression. So really what this ends up being, I mean, if you look at it as they have x squared plus 4 in common, and we got 2x plus 2x, so we've got 4x of these. X squares plus 4. There are several different ways that you could look at simplifying that, but that's really what it boils down to. Or we could also distribute that 4x at that point, and we get 4x cubed plus 16x. It just depends on what form it's in. But remember, I told you a lot of times factored form is more useful to us. So really, I'd probably leave it like this as opposed to multiplying it out for that polynomial. Now, not a big deal when they're squared, but what if, and I went a different direction with this before, I said to expand the binomial, so to multiply it out completely and to find its derivative. Did you get the same result? You should. So what happens if we have something like this, negative 5x minus 11 to the sixth? We don't want to have to multiply that out. Okay, and we don't want to have to use the product rule with 6 terms. So obviously it can't be impossible to find the derivative of something like this. So that means we have a new rule. But we'll get there in just a second. Let's look at these two lists of functions. One of the columns has functions that can be differentiated using techniques that we already know. We can take the derivative of them already. The other column requires another technique. I want you to look at that. I'm going to scroll down here in a second. I want you to look at the two columns, and I want you to see what is the difference between the functions in this first column versus the second column. So first of all, just at first glance, which column can we already take the derivative of? I think it's pretty obvious that it's the second column that we can currently take the derivative of. So pause the video for a second and just kind of look at the differences between the first column and the second column and why we can't take the derivative of the first column just yet. So what we're looking at here in the first column are what we call compositions of functions. Remember that from pre-calculus? Compositions of functions means that they are composed, they are made up of a combination of two functions. So like, for example, with this first one, we took the x squared plus 1, which we can take the derivative of, but then we put it under a square root, which we can take the derivative of a square root, but we haven't dealt with it when it has a polynomial under it. Same thing here. Sine of x, we can take the derivative, it's cosine, but we haven't had a different angle other than just plain x in there yet. So that's a composite. We plugged 6x into the sine of x. Here, With this one, x to the fifth, no problem. Power rule, this one, not so much, because we have this linear expression raised to this fifth power. That's a composition. We plugged 3x plus 2 in for x in x to the fifth. And then obviously the difference here is it's not just tangent of x, it's tangent of x squared, which we haven't done one of those yet. So here's what we're going to talk about. It's something called the chain rule. Okay, the chain rule, because it's kind of like we have a quote unquote chain of functions. So here's our chain rule. If f and g are differentiable functions of x, then y equals f of g of x. Remember, that's our composition of functions. Okay, we have plugged g of x into f of x. So the square root of x cubed, okay? G of x would be x cubed, f of x would be the square root of x. We plugged x cubed into the square root. We'll look at some more examples here in a minute. But here's what the chain rule says. If we've got this composition, then the derivative is the derivative of what we call the outside function. The inside function stays the same times the derivative of the inside function is kind of the way that I put it in simple terms, I guess you would say. So let's look at a few examples of outside function, inside function. Okay, let's kind of label our outside functions and our inside functions here. And my formatting has gotten off. All right. Okay, so the outside function, when we're looking at the sine of 2x, the outside function, the overall function is the sine of x. The inside part is that 2x, okay? That part that's inside of our sine function. All right, the next one, if we look at this, the square root of 3x squared minus x plus 1. The outside part is that square root of x, okay? X is just representing whatever's plugged into it. And the inside function is that polynomial, 3x squared minus x plus 1, that's been plugged into the square root. Now, this next one may be a little bit more difficult to think of. Tangent squared of x. This is how we write our trig functions when the function itself is squared. You can also look at this. If you see that notation, really this is what's going on. We're taking the tangent of x and we're squaring that quantity. So the outside function here is the squaring, and the inside function is the tangent of x. Because if we were plugging in, here's the way you can also think of it this way. When we're plugging something into these functions, where do we go first? Okay, wherever we go first is the inside. Okay, so when we're doing sine of 2x, what do we do first? We multiply x by 2. Then we plug that into the sine function. When we're dealing with the square root one, where do we go first? We plug x into this polynomial, and then we take the square root of it. Same thing here. Where do we go first? In this case, we plug x into tangent, get that value, and then we square it. So then let's look at this one. We would plug x into the 4x minus 5, and then what we're doing is we're using the rational function 1 over x to evaluate that after that point. Okay, so I want you to be able to recognize these functions because it's very integral to being able to take these derivatives. So on textbook page 168, I want you to do numbers 1 through 6 and then come back for some actual practice on the chain rule.